Okay, so hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now in this session, that what we are going to discuss is that today we are going to see late payment prediction, right? So late payment prediction means exactly what? Suppose let's take a different scenario first. I will explain you a real life scenario and then I will take you to this particular scenario. Okay, first of all, see, there are 5 students, out of which one student has been scoring above 80% since childhood, from LKG to class 12th, and remaining 4, they are not scoring that much high. They are like 40%, 50%, second division. Now what are the chances if I pay the fees of medical entrance, right? What are the chances of those 5, and if I pay the fees of their medical entrance test? So it is obvious that the child who has been scoring more than 80-90%, he will be selected, and for rest of the 4 remaining students, the fees will go waste. No doubt they will achieve at least few numbers out of 400 or 500, but the whole fees will go waste, right? Only that fees will be utilized for that one person who has been achieving. So the back history itself tells you hello. So the back history itself tells you that how the fees will be utilized, right? So we can take the decision of the risk, right? Now let's take this example. Suppose we are having so many customers, right? Now here we are having so many customers. Now we are having the history of few customers, they are paying late payment, whereas the terms and conditions is defined for everyone, right? Terms and conditions are defined for everyone, but they are, just hold on second, just hold on. Okay, now whereas the payment terms are defined for everyone, but few customers are paying late and few customers are paying early before that term period. So how to calculate, how to predict that from where we will get the payment as early as possible, right? So this is how we are going to predict that exactly what we are when we are going to receive the payment, right? So first of all, what is late payment prediction, right? So let me make you this. Now late payment prediction is a process that uses data analysis, often with machine learning, to estimate the likelihood of an invoice or payment being received late. That is what I was explaining you. Out of 5 students, 4 are not performing well, but one is performing well, more than 90% since first standard to 12th. Then I will predict that okay, the fees of medical entrance test will be utilized properly on that particular one student, and remaining 4, they will just waste the fees, right? Same thing is, it helps the business identifying which invoices are at higher risk of not being paid on time, allowing for proactive actions like adjusting credit terms or or intensifying the collection efforts. Okay, now see, strategies for dealing with late payment. There are some strategies for dealing with late payment. What are those strategies? Let's have a look. Set clear payment terms and policies. Invoice promptly and accurately. Follow up on late payments. Offer payment plans or discount. Consider using collection agencies. These are the 5 things, right? So all in all, the scenario and the problem is that when we are not when we are having lots and lots of customers and the vendors, when there is a risk of receiving late payment, because it happens very often in business. It happens in business. You will never receive the payment on time. Most of the times you receive early also, but sometimes it could be late also. Now see here, now this is what we are predicting. Okay, now let's have a look on this Excel sheet first. I have downloaded late payment data. Now see, we have downloaded it from NetSuite ERP, right? We are having the customer payment data. We designed the search in such a way that it gives you the customer ID, their payment terms. Look at this. This saved search can be easily created like this. Look at this. Customer ID, the invoice amount, the payment terms, and the days to pay. Days to pay means after how many days he paid the fee, paid the payment. For example, this is the past history, right? So payment term is 45, but he paid after how many days? 40, exact 45 days. That means he paid after 90 days, right? So payment terms is 30 and he paid at 118th day. So these are the day of payment, right? After how many days it paid the fee, paid the payment. For example, if you see, payment term is 90, but he paid early. So that means this is not a late payment. Look at this, late payment. This is not a late payment. This is before time. Payment term is 30 days and it paid on 7th day. So it is not a late payment. So in this way we are having data. We design the search in such a way that we can get the proper output, meaningful output. Okay, now let's have a quick now let's have some practical. So this is what late payment data, right? Now I'm going to create a new iPineUp file, interactive Python notebook. Now first of all, see, since it's the IT field, so we are having the digital data, so we need some libraries on which we can predict. So this is the torch library, torch.nn, then optimization, then dataset data loader, then pandas pd, then numpy, then the matplotlib for plotting. All these things are available here. Now see here, let it pull the data. Now our next step will be now see here what I am going to do here. Once it is done, right now it is under process. So now here pd.read csv, I have read the csv and make a data frame, right? The df means the data frame. Now data frame late payment equal to df days to pay if it is greater than. Now see what happens here. We have taken only those where the days to pay is greater than payment terms, right? df. Now see here, total 5000 rows are there. Okay, now suppose if I make like this, here it is, yeah. So okay, days to pay, as type, that is in. Okay, we have made it as, just a second, late payment. Okay, we have just converted it to int, right? Either 1 either 0. Okay, now what will happen here, we have taken the data first. After that, pre-processing. Now pre-processing means exactly what we have been doing this for the last many sessions. X and y. X is the independent variable and y is the dependent variable. Dependent variable means the value that we have to extract, we have to determine, we have to predict, and the x value which is independent, that means already available. Now here what happens next, here if you see the standard scalar, we have to transform it, right? Scalar value means, for example, let me show you this. Actually, scalar value means it converts the data into -1 to 1. As I have explained you that when a student is let's take a student is in 10th or 9th standard, whatever the books available for course syllabus, exactly we don't write as it is. First we make our notes, prepare our notes, then memorize them, understand them, and after that we write it into the exam. Same thing is here. Directly data will not be processed. We have to first make it standard scalar fit to transform. It converts the data into -1 to 1, and then it will be utilized by the machine learning. Directly nothing happens. Okay, so here if you go x train, x test, y train, y test, train test split function is used here. Look at this, train test split, right? X y test size is 20% and random size, that is 42. That means the data should not shuffle, right? Now let's come here again. Now see what here it is done. Look at this. Now there is a class. Okay, so there is a class of payment data set where torch.tensor, we have converted the x and y into tensors. Okay, and then length, return length, these are the functions that are passing the values. Okay, so train data set and test data set. Train data set means payment data set x train, y train. Test data set means payment data set x test, y test. After that, train underscore loader, data loader, train data set batch size 32. In the size of 32 we have distributed that data, and test loader batch size 32, same. So we have distributed the data. Now train loader and test loader, we are having two variables inside that which we are having the values. Now we are creating the model. Here we are creating the model. So model here, late payment model, right? Then what we have done here, self.fc1 first iteration, right? So in the first time we are providing 4 values, right? Value 4 columns, and 16 is the set, 16 neural networks. So next time these 16 neural networks will become input and 8 neural networks will be created. Next time 8 neural network will be the input and 1 output. That means 1 value we have to determine, right? And then we put the ReLU function. ReLU function is like converting minus into 0 to 1, right? After that segment function is used. Now forward self x. So this is just for passing the value, right? This is just for passing the value. Now here you see model late payment model. Now what will happen here? Look at this, loss and optimizer. We are running loss and optimizer. Criteria equal to binary cross entropy loss, nn.bce loss, and optimizer equal to optim.adam model.parameters, right? Learning rate is 0.001. After that, now see our as usual routine work, that is the training the loop like epoch 50. Now train losses, that is epoch, we are running the epochs. Now model.train running loss, that is we have defined at 0 the initial value. After that we are inputting the data, right? 0 gradient means we are not requiring 0 gradient means it will start from the 0 every time, right? Then the output, that is the backward process, right? Back propagation. After that optimizer dot step. Then you see here the epochs will run. Now how it will run, let's wait. still it is running. It takes a little time. Okay, now you see here the loss, it is decreasing. If you see the loss, whatever the loss we have received here, it is decreasing step by step. Okay, now what next? Here you will see evaluation. Now we are creating an eval module. We are creating the eval module. Now what eval module is doing? Prediction actuals, it extract the data between the predicted values and the actual values, right? So input target, it inputs and targets in test loader, right? Now output, what will be the output? So this is the mathematical complete process with the help of which we have tested the accuracy, that is 99.80. that means it is accurate on data which is 99.80. now what will happen here? So let's take next. Now plotting the actual versus prediction, right? First of all we will plot the actual versus prediction. Now if I show you this, what's written here? Figure and actual is 7, and here you will see actual versus predicted payment. So blue color is the actual and orange is the predict actual. Just a second. Yes, no. Just 1 second. Actual versus predicted, that is fine. Actual and predicted. Okay, actual prediction. Okay, plt dot scatter. Okay, actually it is not showing the blue color. Let me check with this. X, okay, X is a sample. Okay, late payment is okay, no problem. So after this, what will happen? Now we are going to predict on new data, right? Okay, range first. Let's check it out one more time. Actual predictions. Okay, range length, that is actual prediction, actual versus Y level, legend, and show. it show? Okay, y level, x level, here also x level, y level. Okay, the title, then plot numpy. Okay, just a second, let me write here the plot. I think something is wrong here. No, scatter is better. Okay, now here you will see now what we are going to do, predict on new data. Now see, predict new, here we have created only function, right? This is totally technical. Here you will see, you will pass the customer ID, you will pass the invoice amount, pass the invoice term, and then the days to pay. That means how many days after that it will pay. Then what next? Here you will see, now what we are going to pay, send here. Invoice amount is 700, payment terms is 30 days. That means within 30 days you have to pay the amount, and customer ID is this 8270, right? And days to pay. Now suppose, let me show you this. Okay, now suppose if the invoice amount is very less, payment term is 0. Let's take, no, not payment term is 0, customer ID, days to pay, payment term and 30 is T. Okay, now if I take it as 200, since the reputation of this person is, I think, spoiled, so that is why every time it is showing late. Okay, and in this way you can predict the customers or whosoever, right? What they will do, they will predict like this also. So let's have a quick recap also. First, quick recap exactly what is happening here. We are having the history of all the vendors and customers from whom we receive the payment, and we have monitored and we have registered all the payment day also, and when we raise the invoice, that day also is recorded with us, and the fees or the payment amount is not paid and what reasons are given, they are also kept, right? So in this way, the scenario is, what is the likelihood of the payment of being paid late? That's the problem, right? And scenario is the same, and we need to resolve this problem, right? Now first of all, what we have done, we have downloaded the Excel sheet, and then now comes here, right? And this is Jupyter notebook, and now here in this we have first of all imported all the libraries, necessary libraries. After that we pull the data into the format of data frame, then we removed the column, unnecessary columns. First we made it as integer only. After that we will see here the scalar, standardized scalar, right? Standardized scalar function is used here, so it will convert the data into -1 to 1. After that, train, test, split. Now after this, the train, test, split is written here. Here we have taken 20% data for testing and 80% for training, and 42 means the data should not shuffle. Now here if you see the init and the length function, right? So here if you see, we have put the data into the variables, that is train data set and test data set, train loader and test loader, right? Then we created a model. In that model we have taken all the necessary information. Then we created the neural networks of 16 and 8, and then finally 1. Below is the function that runs on that application. Right now, after this, what we will do, we will just put the criteria here. Then we run the epochs, 50 epochs, that means 50 repetition, to make the model trained. And this is all internal working. After working of this, look at this, we have created the evaluation model, right? The evaluation model here is created now, and then we have seen that this is a test accuracy, that is 99.80%, right? And then we plotted the data, and in this way we actually predicted whatever data we plotted the data. After that, what will happen here, we are going to predict on new data. So now new data means we need new fields, right? So we have taken out 3 to 4 fields here: customer ID, invoice amount, payment terms, and days to pay. Right now, with the help of tensors and no grade, all these things, the data is extracted. After that, we are passing the data. We are passing the data here in this function, that is invoice amount, that is 700, and payment terms, that is 330, and customer ID we are providing, which is existing in our database, and days to pay means that we are giving the same value whatever we have given in the payment terms. Okay, now here you will see this customer ID and the days to pay. Now it will predict. See here, predict a new, we have passed the value here, and then it will predict. So if it is late, then it will show late, otherwise it will pass. So guys, it has given you the late, right? So guys, I recommend you to watch this video twice, thrice, because it's a little complex. So if you try to understand in one attempt, it won't be possible. So try to watch this video twice, thrice, and if any error comes, or if any issues, or if you are stuck on any difficulty, then you can let me know about this, right? I will help you there, and at least 2-3 times you should watch this session video. And those who are new for this channel, those who have attended today only, so please share and subscribe my channel. Okay, so let's conclude today's session here only, and then we will see in our next session something new, right? Okay, thank you guys, thanks for attending the bootcamp session. Thank you. See you in our next session. Thank you.